Hey everybody, here's the lesson for today. Sorry I can't be there, um, but Nola was running a fever this weekend, so decided it was best to keep her home, and hopefully she'll be better after tomorrow. But I'll definitely be back at school on Tuesday. So let's get going here. Let's see today. So as we start this new unit, so this is our ninth unit. Basically, just start off. We're going to be doing a bunch of factoring, but a big part of this unit is going to be solving these bigger equations than we've been solving. So, in Algebra 1, you've solved lots of linear equations and started solving quadratics. And then, last semester we spent a lot of time learning how to solve quadratics. And so now we're going to start working on these, third degree, fourth degree, fifth degree equations. How do we solve those? And we're going to start off with ones that are factorable. And then we'll, throughout the unit, work towards ones that are more and more difficult to solve, and then ones that have complex answers, and ones that have imaginary solutions and stuff like that. So it'll be a pretty big unit. Let's see, essential question for today. Why does Nola get sick so often? And if any of you can answer that, we'll gladly pay you to be her doctor. She's been doing something really funny lately. Now when she makes mistakes or finds something that she isn't happy about, she says, "Oh, farts." And I asked her who taught her to say that, and she says, "My body makes me say it." I'm hoping to try to catch her on video saying it so I can let you guys hear it. It's really cute. All right, so I'm gonna start off with some factoring. If you need, if you're struggling with factoring, you might want to get out your factoring flow chart from last semester. A lot of students have found those really helpful, and if that's something that you don't have anymore for whatever reason, just let me know and I can get you a copy of that. So, but we're gonna think about just that. Always starting off with the GCF is our number one friend when we think about factoring, and then from there it broke down into how many terms there were, whether it was two terms, and we had the differences of squares and differences sum of cubes, and then if there was three terms, there's our good old friend the AC method, and if there's four terms, we are thinking about factoring by grouping. But always start with your GCF. So look at this first problem. I want to notice that there is 12 in common, and then they both have two x's. So I'm going to take out that 12x squared. Let's see what's left. So 12 times 3 is 36, and I'm missing an x, and then 12 times 2 is 24, and then missing the y. And as we look, so there's our GCF. And so then we want to look inside of the parentheses and see if there's more to do. So kind of ask yourself, is there more to do? So because we want to factor it completely, not just factor a little bit. So one thing you want to look for is to make sure that the terms don't have anything in common anymore. So 3 and 2, nothing in common. X and Y, nothing in common. And then looking for things like squares or cubes still in here would be a sign that there might still be more to do. But it does not have either of those, so that would be our complete factorization there. Second problem. Let's see, I'm definitely seeing some common factors again. So let's see, you've got 2. They both have 3 y's. So that'll leave me with a 4y squared minus 9. So there we did some GCF factoring. Then, look at that question again, is there more to do? So looking inside there, nothing in common between the two terms, but I do have a square, and I have two terms, and a subtraction between them, so there's a difference, and then both of these are perfect squares, so this would be difference of squares that I could factor out of this still. And so I'm going to bring that 2y cubed down. It's not going to go away. And then remember, difference of squares should be really easy factoring. We want to basically square root both terms. So what times itself is 4y squared, so we get 2y and 2y. And then what times itself is 9, which would be 3 and 3, and then there's always a positive and a negative. So make sure that GCF didn't disappear on you. And then as we look inside, there's nothing in common, there's no more squares, so we should be all good to go. So there's a difference of squares factoring, or difference of 2 squares. All right. Let's see, looking through here, nothing in common for all of them, so no GCF, but we do have 4 terms, so I'm going to look at that factoring by grouping. So cut that there. Let's see what's in common here in the first two. So I definitely have 9 common and x squared, so 9x squared, so that'd be times 3x, and then plus times 5. And then these two don't have anything in common besides a 1, but since that first term is negative, I'm taking a negative 1, and then 3x plus 5 now. So double check, make sure those are the same, of course, and then finish that up. So we have our 3x plus 5s that come together, and then our 9x squared minus 1. So there's our factoring by grouping, and then just kind of run that check again. Is there more to do? So nothing in common, no squares, nothing in common, but we got a square, 2 terms, difference, a subtraction, both are squares. So there's another difference of squares factoring I can do. So the 3x plus 5 drops down, and I need my 2 sets of parentheses with a plus and a minus, and then I say, what times itself is 9x squared? It'd be 3x times 3x. And what times itself is 1? It'd be 1 and 1. So there's our difference of squares. Alright, and then last one, so got 3 terms right off the bat. Let's also make sure we look for a GCF. Got 4s and all those and n's, so I can take a 4n out of everything. Then leave me with an n squared times 3n minus negative 10. Alright, so do a little GCF factoring there. And then 3 terms, probably want to do an AC method, so let's check our AC. So we got an A of 1, a C of negative 10, so our AC is negative 10. Need to factor some negative 10, that add to be negative 3. I bet that'd be like negative 5 and 2. So don't lose that 4n. So n squared minus 5n plus 2n minus 10. We can break that in half. Don't lose that 4n. So I take out an n of both, I leave with n minus 5. Take out a 2 out of both. So something I've noticed a few of you doing is that, like I just wrote that 2 there, is not okay to write that way. There does need to be a plus sign right there. So it's something that you do lose a point, half point, 0.4 on a test. So it's something you want to be in the habit of making sure that it's plus sign there, not just a 2. Just one of those little particular math things we got to make sure you're communicating well. So that'd be 4n times, let's see, n minus 5, and then n plus 2. So some AC method factor in there. So, all right, so there's just a quick factoring review. We'll be using a lot of factoring today as we are solving these equations now. So really not too much different than anything you've done before. Once we get done factoring, we're just going to set each factor equal to 0 and then find our values for x or for n or whatever. So which you guys have done with the quadratics, that once you're done factoring the quadratic, you just set those parts equal to 0. So really, today should be pretty simple as far as there's not like a lot of new ideas, just getting that factoring gears turning. And so let's see, we want to find the real number solutions. I just want to kind of highlight that when we talk about solutions, there's other phrases for solutions, and I know we brought that up. I just want to keep talking about that solution is also known as an x-intercept. It's also known as a 0, and it's also known as a root. So we're finding those x-intercepts, we're finding those zeros, we're finding those roots. This is just something I want to keep talking about because it's going to be brought up throughout this unit. So keep hitting on that. I'm going to make sure that when we are solving one of these equations that one of the sides is set equal to 0. So just kind of checking that real fast. So we have that. And then we want to factor it. And again, once we have the factors found, we're going to set each one equal to 0, and then we'll have our solutions then. So we've got 4 terms. Check over real quick. Nothing in common between all of them. So going straight to factoring by grouping. So I can take what? An x squared out of both of those. And it's going to be with a 2x and a plus 3. Then out of here I can take a negative, 9. So it's going to give me a 2x and then a positive 3. And that's going to equal to 0. Don't lose that equals 0. Finish our factoring. It'll be 2x plus 3. X squared minus 9 equals 0. Oh, there's a difference of squares. So let's make sure we finish this. So 2x plus 3, and then x minus 3, and x plus 3. So I love difference of squares factoring. It's so easy. Just got to recognize it. So, all right, so last thing I'm going to do is set each factor equal to 0. So 2x plus 3 equals 0. So I'm going to subtract 3 to both sides. So 2x equals negative 3. And then x equals negative 3 over 2. I would always just suggest you guys leave things as reduced fractions, so no point in turning that into a decimal or anything like that. So there's one of our answers. And then x minus 3 equals 0, so x equals 3. There's another of our answers, and then, of course, x plus 3 equals 0, and so x equals negative 3. And you guys should be getting pretty good at doing really at least those last 2 in your head, if not all 3 of them in your head. So there's our 3 answers, and I guess I didn't mention this at the beginning. This is something we'll hit on more again, also some more foreshadowing for the unit, that this problem should have 3 answers. And I think, I know it's something I mentioned to my students last semester, hopefully all your teachers did, that you always know how many answers a problem should have at the beginning because of the degree of the problem. So that highest exponent will tell you how many answers there should be. So this has 3 answers. So there we go. So it's just something to think about. It's like, what should I have when I'm done? I should have 3 answers. Okay, 1, 2, 3. Boom, boom, boom. So kind of making sure you kind of answer the question fully. So, all right. So let's head right off on that note then. So, right, that our problem should have 3 answers. So then let's see, we got some GCF we can do. So I notice they all have an x in them. So I got x squared minus 7x and then plus 10 equals 0. And so definitely a little bit of the AC method here. I think this would be a good time to talk to you guys about a shorter way to do the AC method for some problems. And this is always a little reticent to bring this up because a lot of times students will start using the shortcut when they shouldn't. And so it's just really, really important that we've taught you the full AC method, and it always works, but the shortcut works sometimes. You got to be really careful about that. So our AC is 1 times 10, so AC is 10. I'm going to do it the full way, and then I'll show you the shortcut when we're done and see if we can apply it later. So new factor is a positive 10, that would be negative 7. Sounds like negative 5 and negative 2 would be my guys. So x half. Don't lose that x. So we got to take an x out. X minus 5. Take a -2 out, so x minus 5. Always keep that it's an equation, so don't lose those zeros. I know it's easy to forget those. And then x times, so I'd have x minus 5 and x minus 2. So what about that shortcut you're saying, Mr. Baker? So now that we're done factoring. So I'd like to point out that we could have skipped all of this right here. We didn't need to do any of that. We actually knew what the answers or the factors were going to be when we, without doing all of this. So if I can notice that there's a minus 5 here and there's a minus 2 here. Well, look what's right over here. So this only works if your a value is 1. That the two numbers that multiply to be the AC and then add to be b will be the same two numbers that are in the factors. So we did that up here, so I'll show you. All right, so what are my factors of -10 that add to be -3? Well, we said they were -5 and 2. Well, there's that -5 and 2 right there. So again, our a value was 1, so it worked. So get really careful. That's, I like to call that the short AC method or the easy AC method. And so I know when I'm talking to my college algebra students that we really kind of define it that way. Because we just want to do it faster when we can, when we're allowed to, so without sitting there going through the full AC method. So just be able to jump from here to here in one line just saves you a lot of time, especially something like the ACT or something like that. That to be able to factor faster is going to be important for you guys, and especially when we're doing lots and lots of factoring, that if you can just do it faster and save yourself some time, makes the problems a lot easier. So if that's something you're really not sure about, but you want to be able to do, of course, I'm more than willing to help you guys with that. And it's, back in class, I'll be kind of highlighting that some more. But again, only if a is 1 are you allowed to do that. You can go straight to here. So you got to be really careful to not use this shortcut improperly. So, all right, last step: set each factor equal to 0. Don't forget about that x. So x equals 0. There's one of our answers. Love that guy. Of course, here just switch that sign. X minus 5 equals 0, so x equals 5. Easy peasy. And then x minus 2 equals 0, so x equals 2. So there's our 3 answers, just like we said we would have. So don't forget about checking that. All right. We got a couple more examples to do, and then we'll be done. All right, so here's a little reminder I had for myself. So we went to a children's museum this weekend. It was so funny because all of the artwork was on refrigerators. Ha ha ha. Then we went to a different museum and had all the arms and legs that were missing from all the other statues in all the other museums. So good times. Let's see what's going on here. All right, so the only thing that's different about these two problems here is that we don't have our problem set equal to 0 right after that, so it's just going to be our first step. Just get that one side equal to 0. So no biggie, just something to remember. So first thing I want to do, move towards the bigger exponent, so I'm going to subtract the 75y, both sides. And good old friend a GCF will be our first factoring, so I say a 3 and a y in both terms, so I leave it the y squared minus 25. That's not a 2. And then we got some difference of squares factoring there, so 3y, and then y plus 5, and y minus 5. Even difference of squares factoring could be thinking about it as an easy AC method problem, because our a is 1 here on this problem, at least. And then so a times c would be -25, and then our b value would be 0. So what are factors of -25 that add to be 0? Well, 5 and -5. And there they are. So I can kind of just prove that to you again. So 3y equals 0, so divide by 3. So y equals 0, there's one of our solutions. Again, we should have 3. Of course here, y equals -5. And then from here, y equals +5. All right, so those are the values of y that would make the equation equal to 0. All right, one last normal problem. Then right up there in the bright lights, we're going to make sure we get one side equal to 0, so minus c squared. Again, always moving things towards the bigger exponent. So I'd have z cubed minus z squared minus 25z plus 25. That equals 0. So this is definitely something I'd want to be seeing, that you're writing those equal zeros. Just warn you about that again, and I've already said it. So there's some factoring by grouping. So I'm going to take out a z squared. That's going to leave me with z minus 1. Here I'm going to take out a negative 25. That's going to leave me with a z minus 1 equals 0. So I get z minus 1. Z squared minus 25 equals 0. And then there's another difference of squares. Z minus 1. Maybe z plus 5 and z minus 5. Alright, and so the last step, so z would equal positive 1, z would equal negative 5, and z would equal positive 5. Again, those are the values that would make the equation equal 0. That's why they're called zeros. And we knew we should have 3 answers because of this. So, alright. So last of kind of the abstract, just like regular old algebra problems. Then we're going to go to one application. You guys have one problem pretty similar to this in the homework, so just word of the wise, how we pay attention how we do this one, and it'll let you know how to do that problem there. So I'm going to find all possible values of x. So it could be more than one answer. Here's what it's saying. It's telling us we have an area of a rectangle, and it's giving us these expressions for the sides. Well, how do we find area? Length times width. So we're going to take those two expressions, one being for our length and one being for width, and we're going to multiply them. And so I'm going to take that 3x minus 4 and that x plus 5. And we're going to multiply them, and then when we multiply them, we should get what the area is, which tells us is 40. So set it equal to 40. So doing a little FOIL double distribution, I get 3x times x, so 3x squared. 3x times 5 is 15x. Negative 4x. Negative 4 times 5 would be negative 20 equals 40. So I'm going to do a couple things at once. So I'm going to get one side to be 0, so I'm going to subtract 40 to both sides. But I also have a couple of like terms to combine. So it's going to give me 3x squared. And then 5x minus 4x, 11x. And then negative 20 minus 40 would be negative 60 equals 0. All right, so AC method, 3 terms, right? Nothing in common. So I cannot do the regular AC method here because A is not 1. Or I cannot do the short AC method, sorry, because A is not 1. So I would need to do full AC. Okay. So I would take A times C. So our AC would be 180, or negative 180. I need factors of negative 180 that add to be 11. And I have no idea what those are. Actually, now I think about it, I do, but let's talk about how we would get it otherwise. So 1 times 180, not going to get 11. 2 times 90, not going to give me 11. 3 times 60, not going to give me 11. 4, we go up 4 times 45, no 11 there. 5, let's see, 40 minus 4, so 36, no 11 there. 6 times 30, getting closer. 7 does not go into 180. 8 does not go into 180. 9 times 20. So there's my 11. 9 and 20. So we got negative 9, positive 20. So let's see. 3x squared minus 9x plus 20x minus 60 still equal to 0. take a 3x out of both. Leaves me with 1x minus 3. Let's see, take a positive 20 out of both of these. Leave me with 1x minus 3. And equals 0. And let's see, 3x plus 20 times x minus 3 equals 0. Alright, so set h1 equals 0, so 3x plus 20 equals 0. So subtract 20, so 3x equals negative 20. Divide by 3, so x equals negative 20 thirds, which is a little bit more than 6, about 6 2/3. So we 6 and 6 repeating. And then this one, so x would equal 3. So we got our two answers. We should have gotten two answers. It said that we could get two answers, right? Well, multiple answers. We knew there should be two because of the square. So got our two answers. Problem is, if we plug both of those numbers in, like if I plug 3 in here, so I can find out that that would be 8, and then 3 times 3 is 9, minus 4 is 5. And 8 times 5 is 40. Check. But then when I plug in negative 6 repeating plus 5, well, that would make that side negative 1.6. And I can't have a rectangle with a negative length, so this is what's called an extraneous solution. So it doesn't actually work. Mathematically it works, but only the 3 actually works mathematically or realistically because of the shape we're looking at here. So make sure those real life problems that negative numbers usually don't work. So check those right out there. And that should not be a new idea. I should have heard that from last semester. So and this semester too, I think. So hope you guys have a great Monday, and I'll be seeing you Tuesday. Homework's right down here at the bottom of the page, so don't forget about that. You guys should have a good amount of time to be working on that in class and whatnot, and definitely have that done. And I'll be working on getting your tests graded today while I'm hanging out with Nola. So take care, and I'll see you guys Tuesday. Bye.